Welcome everybody. We're here again today for another episode of Science Live from the Creation Museum and the Science Education Lab. And today I'm joined by Dr. Georgia Purdom. So why don't you just take a second and tell everybody what you do here at the ministry.
Okay. So I have a PhD in molecular genetics, so I'm a scientist here. I'm also a writer, a speaker, and the director of educational content. So overseeing a lot of the programming, educational programming that we offer here at the Creation Museum.
Mm-hmm. So she's my boss, really.
So I'm watching him very closely today.
Yes, she's keeping an eye on me today. All right, so we're going to be giving everybody a couple seconds to get notifications and all those things to go out. And we're going to be talking today about paper chromatography. So try and figure out what that means before we get started. Yesterday we had some good fun with combustion. We got to scare the cameraman when that bubble popped and burst there. So another thing, I was a little disappointed that none of you pointed out that Claudius was down by my feet while we were out shooting the potato cannon. So Claudius is going to appear randomly in some of these videos. So you may have to go back and look at the video from the potato cannon, the combustion episode, to see if you can find Claudius in that. But he'll be making some guest appearances and some stealthy appearances. So if you see him, point him out. And
yeah,
let
you can put it
know.
here in the Facebook Live. So
Yep.
I'm watching here, and so you can let us know.
Okay, so today our topic is chromatography. So another big fancy word, but let's think about what it means. Chromo is the scientific word we use for color, and graph means where something's positioned. So we're going to talk about the different inks and dyes. So if you think about things that you might have around the house that contain different inks and dyes, things like markers that you have, or even crayons and colored pencils and all of those types of things. All of those have inside of them different pigments, and a pigment is something that reflects light, and when that light bounces off of it, it hits your eye. So if you think about a rainbow or the color spectrum, we typically think about the colors red, orange, yellow, green, blue, indigo, violet. Right. Even though there are millions of colors in a rainbow, that's just a simple way to think about it. Each of those colors is present in the white light. So for example, the lights that are above us in the room today are sending a white light, and it's bouncing off of this blue cap on this marker. And every other wavelength of light, all the red, all the orange, all the yellow, all the green, all those other colors are being absorbed by the pigment, but the blue is bouncing and hitting me in the eye, and my eye has these little receptors in it called cones, and the cones detect the different colors. And then that's interpreted by my brain. So it's a very complex process that we think about when we think about seeing things. I do a whole workshop here at the museum on understanding color and how that works with light and all of those different things. So we're going to look at some of the different pigments that go into making these dyes today and try and understand a little bit more about them. Any questions coming in yet?
Not yet. We have
Okay.
somebody is saying Claude's name on here. So I don't know where it is. They didn't say where it was.
Claude.
But
okay.
we also have someone on here from Queensland, Australia.
All right.
So watching
Seen those.
halfway across
we
the
had
world.
Someone from Malaysia commenting yesterday, so that was pretty exciting.
That's neat.
Okay. All right, so if we think about different types of markers and even different inks and pens, all of these have different types of dyes in them. Now, what you may not know is that if you'd had a whole bunch of different red pens, they don't all have the exact same red dye in them. Every manufacturer and even different manufacturers have different formulas for the different types of dyes inside of the inks. And so we can actually look at these different pigments and the dyes inside the inks and separate them out into their different colors. So how are we going to do that? The technique we use is called paper chromatography. So here's a little scenario we can set up, a situation I've got going. We have a thief in our midst. Somebody ate my muffins this morning. They took them out of my bag and they left me this little note. It says, "I ate all your muffins. They were yummy." So thanks to my wife for making those yummy muffins. But the thief has taken my muffins. So what I could do if I wanted to investigate this is I could extract some of this ink off of here and then run it through a paper chromatography and try and figure out which pen made these marks. So I went around this morning and found 5 culprits and I took the pens off of their desks, and these are the different pens that I found. And I've numbered them with the suspect's numbers. And what I did is I placed a dot of each of them on these papers. So this is the evidence sample. This is the one that I took off of the note. And then pen number 1, 2, 3, 4, and 5. And we're going to try and figure out which criminal stole my muffins.
So we have some forensic science going on here
Yes.
too, right?
So this is a forensic science technique. Now this isn't exactly like what they'd use in a criminal case,
Right.
but it's kind of simulating that. So we're gonna do this, and we're gonna try a couple different solvents. Okay, so a solvent, go ahead and fold that into approximately thirds.
Okay.
So it will make a nice little tent. Okay, we're going to try a couple different solvents here. A solvent is something that dissolves another substance. We talked about that the other day when we were talking about salt water. So we're going to try 2 different solvents in our experiment here. For mine, I'm going to use a mixture of alcohol and acetone. So alcohol is what you might find in alcoholic beverages, or things like isopropyl alcohol would work for this. And acetone, for you ladies, is what we use to dissolve
Nail
your
polish
nail
remover.
polish. Okay, yeah, nail polish remover. So this is something you could do at home, and we're going to squirt in a little bit of this alcohol, just enough to cover the bottom. And Dr. Purdom is going to use water for hers. Yep. And we're going to see what happens here. So what you see happening, if you look closely, is the solvent, this alcohol and acetone mixture, is moving up the face of the paper. And you can probably tell that it's starting to take some of the ink with it. All right? So all you need is a little bit in there, and that should be enough.
Just enough.
Mm-hmm. And we can see the ink is being dissolved by the solvent and moving up the face of the paper. So if you think about the paper is made of a bunch of little overlapping meshes of fibers that are all smashed together in a network or a weave. And these pigment molecules, some of them are big and some of them are small. And so they're trying to fight their way through this paper, and they're being pulled along by the solvent. And the bigger molecules are going to have a harder time moving through the paper. Just like if I were trying to go through a little jungle gym maze, I'd have a hard time getting through because I'm a giant.
This is true.
But somebody smaller would be able to get through much more quickly.
Somebody spotted Claude.
Oh, there's Claude hiding back in the background.
He's behind the sign, right? And someone asked, let's see, what if someone used someone else's pen?
Oh, we'll talk about that in a minute. Okay, so you can see here, as these inks are starting to separate out, the alcohol is moving along and pulling those things up. The water as well. Now notice the big difference between what's happening in the water and what's happening in the alcohol. Almost none of these different inks are moving along, only the one that matches the evidence. Okay, so some inks are soluble in water and some are not. So this is one way that we can distinguish between different inks. We could say that these inks are not water soluble, but they are soluble in alcohol and acetone. So we get different inks will dissolve in different things. So you could do a test at home, taking a piece of paper, doing something like this, and making a mark across the bottom. Now for the mark across the bottom, I used pencil. Why do you think I used pencil?
Because the pencil is not going to dissolve in either the water or the alcohol.
Okay, so the graphite, the carbon there, isn't soluble in water or alcohol, so it's going to leave me a mark so I can know where my starting point was. So use a pencil, make a line across the bottom. You can do this with about any paper you've got around the house. It should work, as long as it doesn't have a plastic coating on it.
Right.
Avoid any papers with plastic coating. Okay, so if we pull this out here now, we can probably set this one aside and start to dry it out and look at it. You can obviously tell that the ink pattern in this one matches pen number 1. And if we look over here at Dr. Purdom's water sample, the same thing would be true. We wouldn't think these were the suspects, okay? So as a forensic technique, this would allow us to see which pen we think may have made these marks. Mm-hmm. So the question is, does that mean the person who had pen number 1 was actually the thief of my muffins?
Well, no, because it could be that someone used that pen to incriminate that person,
Okay.
even though they're not.
That'd be a
really.
possibility.
That would be one possibility.
They could have taken it from someone else's desk and used that. So
Right.
then we could use techniques like fingerprints or security cameras or other types of things that we would have available to be able to see who actually stole my muffins. And we could use that as a starting point, and we could think about who that was and what happened there. So if I were to find that person, what would I do to them? Well, if justice were to be served, we would think about repaying the penalty, but then I would have to consider whether I'm going to extend forgiveness to that person. So when we think about criminal justice, it's a great connection to the gospel. As I think about all that God has forgiven me for sinning against him, I can then extend that forgiveness to others, and that's a way that I can demonstrate the kindness that God has shown to me toward others. So even in discussing things like ink samples, we can see connections to the gospel and how we can point people to Christ in these things.
Yeah. Somebody had asked, do different brands of pens have different kinds of ink? And the answer is yes, because you can even see that here, because some of these are more purple. This one's like blue and purple, so you can see a lot of differences in the types of inks. Even though they're all blue pens, they have different kinds.
And this is the same samples that I've let run over a little longer period of time. And you can see even between sample 2 and sample 3, you have a lot more blue ink in here and a lot of this purplish ink in here. And so they're being distinguished in various ways, so different inks. This would be a great thing for you to do. Find every red pen you can in the house and do a sample like this and see how many different inks and pigments you can identify. I did that also with a bunch of different types of samples. So, we're gonna do another little, while we're letting this run. Dr. Perta made some beautiful art on this little paper here. We're going to put it in the solution, the alcohol solution here. She used these markers.
These types of markers.
Yes, the markers over here to make this pattern. We're going to set it in here, and this is another fun thing you can do at home. We'll just scoot this off to the side for a second and let it run while we talk about these other things, and we'll come back to that in just a minute. So here's an example of lots of different red inks. We're going to turn the lights off here in just a second so we can show you something else. Here's an example of a bunch of different red inks that I used. So I found different pens around the office that use red inks. And another amazing thing about inks is manufacturers will often put UV dyes into them. So if you look at those samples, you can probably see the paper glowing where the ink is, especially on that 4th sample. Got a lot of bright glow there. Okay, so there are UV dyes to make things bright. I took M&Ms and I dissolved.
I love it.
I dissolved the dyes off of the M&Ms. There's what it looks like under normal light, and then here under the UV light, you can see that yellow one really glows. So it's got a lot of UV pigments that show up in the UV range as well, and so do the red ones. Here are all these different wet erase markers. I put each of them on the paper, and you can see how there are different dyes in all of those and the different colors. And these don't have as much of that UV dye in them because they're not quite as bright. They're not made to be that way. Another thing I did is I took a bunch of plants from out in the Creation Museum gardens, and we found different colors, and we smashed them up with in a little pestle, mortar and pestle, and then extracted some of the pigments with alcohol and put them here and ran them through the chromatography. And this is the amazing thing. You can see, that there are actually a lot of UV pigments inside of those plants. And those are things that insects use to find the flowers. So you can see those UV lines showing up. Okay, so even in plants, God has put lots of beautiful colors, but also UV lines that our eyes can't detect that other insects can, and they can use those to find
I've seen
plants and
pictures.
things.
Sometimes they'll take pictures of flowers, especially under UV light, and they're just amazing because there's this whole other pattern that actually is drawing the insects in that they can see, but we never actually see.
So if we look at one of my favorite, it's called a potentilla. It's a tiny little yellow flower, and it just looks like a yellow blob if you stand back 10 feet away from it. But if you shine a UV light on it, it's like, here's the pollen.
Yeah,
These
come
big
here,
lines,
like
right?
arrows.
The big lines, come get my nectar and spread my pollen. So God's made
Somebody
an
asked
amazing
a
creation
question.
out there.
Kinley, 7, in Virginia, is wondering, what does UV mean?
Okay, so when we think about our visible light, the light that we see from red to violet. So ultraviolet means wavelengths of light that have a higher energy than violet. So out beyond the purple. We can see a little bit into the UV range, but lots of animals and insects and other things can see far into the UV range. UV light is higher energy, so it's the light from the sun that we're worried about damaging our skin and giving us skin cancer.
Right.
So that's why we would wear sunblocks or wear long sleeve clothes when it's
Because it can
outside.
mutate our DNA.
Yes, and Dr. Purdom can teach us all about that. On the other side of red, on the lower end, you have infrared. So that's IR light. That's what we would use in night vision goggles. You can see things that are giving off heat with these special glasses that detect that infrared light. So even though our eyes can't see those under normal circumstances, we can use tools and technology to help detect those things.
I have another question. Okay. Heather, 8, says, does the UV color help with photosynthesis too?
As far as I know, the pigments in chlorophyll that absorb that light do not absorb in the UV spectrum. They're primarily focused in very specific wavelengths of light. And there are different pigments. You have keratines and chlorophylls and other things. And each of them is specific to different wavelengths of light. And that can even be affected over different times of the day. They're absorbing different types of light, but not UV.
Somebody else wants to know, can dogs see UV light?
Oh, that I don't know.
I don't know either. I wouldn't think they could because they're mammals, and most mammals, as far as I know, cannot detect UV light.
As a deer hunter, I do know that deer have a higher detection range in the UV, and so when I'm washing my clothes, like this shirt probably has a lot of UV brightened dyes in it. I wouldn't want to wear this out in the woods while I'm hunting deer because they would be able to detect that. So I use a special soap that doesn't have UV brighteners like a lot of the laundry detergent.
Who knew?
Who knew? Crazy things you learn hanging out with Mr. Patterson.
Yep.
All right, let's take a look at this beautiful art that Dr. Purdom has made.
Look at that.
She doesn't fancy herself an artist, but if you take a look, this is something that you guys could do. I've got some other examples we've done with things like coffee filters. Oops, that one's blank. That one's not very exciting. That one's kind of ugly, but you can see all kinds of different patterns you can make. So this one wound up looking like a cat.
Oh, that's funny.
See the ears on it, the way it was folded. So you can fold these into little patterns. You could do these with snowflakes. These
it's kind of like tie-dye almost is what it reminds me of.
Yep, you can see all the different pigments in the inks blending together, all these different patterns we can get. And just a reminder of the beauty that's all around us in nature, the beauty that we can create as image bearers of God, being reflections of His creativity in the earth all around us. All right, so some fun things you guys could try at home and learn about all the different pigments and dyes that are in different inks and things that you've got around the house. Some things might be soluble in water, some things might not, some things in alcohol. You can use isopropyl or rubbing alcohol and maybe splash a little fingernail polish remover in there if you've got it. But great things you can try out at home. So Dr. Purdom's going to wrap us up with our final thoughts today.
Okay. So we wanted to, we try to feature a product every time, and today we're featuring Chemistry 101, and this is a great chemistry curriculum for high school. I'm using it currently with my daughter, who's a sophomore, And it has a lot of different presentations on it. They're all about 30 minutes long. And then it also has, there's a PDF of a booklet on here, a book that goes along with it that has quizzes in it. And so it's really great to use for, like you could use it for a homeschool curriculum, but even if you're attending a private school or public school, it's just great information, a lot on the history of some of these elements, how they were discovered, what they're used for in everyday life, so to speak. I don't think we appreciate that so much, just like the colors that we don't necessarily think about. So this is a great curriculum, and right now we have 20% off. So you need to use the code Matthew6. Go to our web store and you can find Chemistry 101 there and get 20% off that. We also have a couple more live streams that are happening today, as always. So at 12 o'clock at noon Eastern will be Brian Osborne, and his talk is entitled Noah's Ark and the Flood, We've Got Answers. So that's appropriate on a rainy day that we have here. And then Ken will be at the Ark Zoo at 3 o'clock today with our mystery animal. So you're going to have to find out. You're going to have to watch
what's happening
at 3 o'clock to see what he's going to be talking about there. And then at 7 o'clock, we have a very, very special event going on. There is going to be a sort of mini concert with Steve Hess and Southern Salvation, who's our group that performs down at the Ark, along with Ken, who actually, I don't know how many of you know this, but he is an excellent pianist, and he plays
the first
very,
time
very
I
well.
saw Ken playing, I was like, oh,
I know.
Ken
I was
can
like,
play the piano.
whoa, that's pretty cool. So he is very good. Oh, so someone wants to know who ate your muffins.
I actually ate the muffins. There was no thief. It was actually me. So I confess to the crime. But
Yeah.
All right. Thank you for joining us again. We plan to be back with you again on Monday, so be watching for that. We hope you'll be sharing these with all your friends and family. And until we get back again, get out and explore God's creation.